Welcome back, you know the score. Raw Code Academy's live, we're knocking at your door. With knowledge bombs and tech that's red hot. Cloud native AI, yeah, we've got a lot. From ORAS to OCI, the future's in our sight. Managing models day and through the night. Kubernetes clusters and registries so grand. We're taking AI ML, putting it in your hand. Today we're diving deep, no time to delay. With experts in the house to light up your way. Josh Duffney's in the mix with insights so keen. And Fame and Zoo's here too to make the vision seen. Ollama models packaged up so tight. OCI artifacts shining ever bright. Mountain volumes, Kubernetes style. Cloud native AI, gonna go the extra mile. So buckle up, folks, get ready to learn. From challenges faced to lessons we discern. We're building the future, one artifact at a time. Raw Code Academy's live, let's make this paradigm climb.
Hello and welcome back to the Raw Code Academy. I'm your host David Flanagan, also known across the internet as Raw Code. In today's session, we're going to take a look at running AI ML workloads on Kubernetes and all of the fun, interesting aspects of doing so. There's a lot to learn here today, and we've got two fantastic demos from two fantastic people from Microsoft. So let's move over there and meet them now.
Hey everybody.
Josh, Dave Henman, how are you?
Good. I just have to say to start, that is probably the coolest intro music that I've had or I've seen. So props.
Yeah, well, you know, it's only fitting that we're doing an AI ML episode. We have some AI generated music, and I love that you can just, I mean, it's just so available these days. It's amazing what AI can do for us. And, you know, there's a lot of cloud infrastructure, CPU, GPUs working behind the scenes. And hopefully today we can give people a bit of insight on how to do this correctly, properly, safely. I'm not sure, but I'm interested to find out. Could you both please take a moment to introduce yourself to the audience and share a little bit about you, please?
Sure, I'll go first. So my name is Josh Duffney. I'm a senior cloud advocate on the cloud native team inside Microsoft. Been in the role a couple of years. Before that, I was an SRE at Stack Overflow, and then a DevOps lead in previous roles. So it was kind of a good natural progression and fit for me, but I really enjoy the work. And then kind of, you know, just a little bit more background on me, mostly write in Go, but starting to write in Rust and kind of float around a lot of C and CF projects and contribute and do conference talks and stuff like that. But that's kind of like a TLDR on me. Feynman, over to you.
Yeah, my name is Feynman. I'm a CNCF project maintainer and currently maintaining CNCF Notary project, ORAS, and Ratify. Notary project and ORAS will be the major focus today because we're gonna share how to manage and run AI and machine learning models as OCI artifact with ORAS, and also verify it with notation. I'm also a product manager for Microsoft Azure. I have been working on the secure supply chain over the past 3 years, and I enjoy the work, including open source and securing supply chain.
All right, awesome. Thank you both so much. Let's start off with a couple of questions, and then we'll ease into the demo today. But you know, I've been in this Kubernetes space for a while. AI and ML workloads are very new to me. I've got to say, running them on Kubernetes does fill me with a little bit of fear, because when I think of Kubernetes, I think of stateless services, small containers, low memory and CPU footprint, and bin packing as much stuff into a single machine as I can. But everything I know about AI and ML is, gigs, terabytes, petabytes of data being shifted about. I've seen some crazy container image sizes that I don't even want to think about. Is Kubernetes important in AI and ML workloads, and how do we make that sensible for people that are watching? Just feel brave.
Do you want to take a stab? I can take a stab if you want, Feynman.
Yeah, you can go ahead.
For me, it just kind of brings me back. Containers started about the image size. If you look back, like even the Windows containers, I know they're not as popular as the Linux containers, but they started around that same size. So Kubernetes as a platform, so to speak, can handle that type of size. I think where it's most appealing for me to use Kubernetes is just the orchestration and the abstractions that it gives you in being able to move components around. So I would hate to give up that flexibility of the orchestrator from a deployment perspective, and then being able to have everything in YAML, as much as YAML is a pain to work with. From the CI/CD perspective and the velocity that you can achieve with those systems, I think is still pretty important. Granted, our image sizes are increasing again, but it's really not too different from a recent past, to be honest.
All right, awesome. Yeah, I mean, we've already got now 10 years of expertise of Kubernetes under our belt, and as we explore these new workloads, which are AI and ML based at the moment, I mean, everything seems to be going this way, especially with agentic workflows now. There is a potential future where we don't even write software anymore. We're just writing LLM agents and then having them talk to each other. Like, I don't know how far away that is, but the AI buzz would tell us that it's next week, or it was last week, and we're just not caught up yet. It's hard to tell. So yeah, I'm very excited for today's session. Can you both take a minute just to tell us what you're going to be showing the audience today and what they're going to walk away with?
Sure, I'll let Feynman go first because he's doing the first demo.
Yeah, today we're gonna walk through the challenges of managing AI and machine learning models in cloud-native world, especially on Kubernetes. And then we're gonna briefly share what is OCI, the OCI standard, Open Container Initiatives, and also what is the CNCF ORAS project. And next, we're gonna briefly share the Notor project. I remember we have another fellow, E, who dived into the Notor project and Ratify for signing and verification. But today, we're gonna demonstrate Notor project in another aspect, which is sign and verification of the AI models, right? And we will have two demos today. The first one is to package and run AI models as an OCI artifact, and we can push it to the OCI registry. And the second demo will be taken by Josh to demonstrate how can you sign and verify your AI models locally and distribute it via OCI registries.
All right, awesome. Well, thank you for sharing. I think it's about time we share a screen, get hands-on, and show off some pretty cool open source technologies. So let's jump over to the screen share. All right, take it away, Feynman.
Awesome. Thank you, David. So when we're thinking about managing AI or machine learning models, what's the challenges come in your mind? Actually, I'm not an AI expert. I'm also quite new to AI, but what attracts my interest? Actually, we have seen a lot of customers and community fellows who are asking questions like, hey, we have a very large size LLM models. How can we run it in a container? How can we containerize it and make sure they can be stored in a centralized place, just like OCI registry? And how can we distribute it to different platforms and also from dev to production? And eventually, they want to build a central platform to host those models and also securely distribute it from on-premise to multi-cloud environment. That is the questions come from our real customers and the real world. we have seen users like Bloomberg, Red Hat, and also a lot of end users. They are trying to store their AI models in the container registry. That's very magic, right? So previously, our awareness about the container registry is that we just use it to store container images and maybe Helm charts, right? But with the new standard such as OCI 1.1, we are able to store anything in an OCI registries, such as arbitrary files, supply chain artifacts like SBON and signature, and also maybe even AI models in a central place, right? So here's the thing. So we have seen a lot of customers and industries are complaining about we lack of a unified standard to manage and distribute AI models in a cloud native world. So basically, the lack of the standard to make the model management have versioning and reproducibility, because AI models is evolving very fast. They may have multiple versions, but they didn't use Git and OCI to manage those versions. So versioning and reproducibility might be the first challenge for the industry. Second, as we all know that the AI models sometimes have more than at least 1 GB, right? It's very large. So it's a big challenge for them to distribute it from their local to the remote securely. How can they secure the AI model distribution? That's another challenge. And how can they transfer those models from their local environment to maybe different cloud platform and eventually running it on Kubernetes? Even more, they are thinking about how can they deploy it in an efficient way. So those are the challenges that we have been observed from the industry and also from our communication with the customers, with our communities. Okay, so the AI or AI infra, machine learning infra developers, they may want to use the same tools without any change. They want to have minimal change in their workflow to achieve a unified management norm in their AI or machine learning standard, right? They want to have easy model evaluation and deployment. Those are the real requirements that we heard from the communities. But from the engineering perspective, so we may receive the request from the engineering team that they want to ensure the software best practice by following the engineering conventions. For example, they want to have the model files management immutable, and they want to have very strict versioning for the model development, because in their mind, models are also just normal software. There's no big difference between between other software and models. So they want to have very strict immutability and versioning, as well as proper release process and DevOps. They want to automate everything, right? Because they are facing a bunch of pain points to manage thousands of the software delivery in the company. And also they want to make sure the model distribution and deployment meet the security and vulnerability checks and will eventually meet the company compliance criteria. So that comes to a problem. Should the ML or AI developers host those models on a separate model registry, such as Ollama registry, or they want to build an additional Snowflake? But from the engineering point of view, they want to have a unified platform. Maybe it's an OCI registry, maybe it's an S3, it's a S3 bucket, or is a blob storage. So the thing is too, people want to unified model management and also the model distribution in a central way. Okay. I heard a practice from Bloomberg. They demonstrated how they are currently manage thousands of AI models in an OCI registry. Because they have been noticed there are several benefits of using OCI registries as model registry. First, they can easily standardize the packaging process. So let's say, for example, they can package the AI models as OCI artifacts. With OCI 1.1 standard, there's a property artifact type. They can easily to define the type of the AI models and package it into an OCI artifact, eventually store the OCI artifact in the container registry. This should enable consistent distribution across different cloud environments because the OCI artifact will be stored in a central container registry. Then users can pull the container image or the OCI artifact from the registry and easily distribute it across different environments. And also, all of those dependencies can also be packaged together with the AI models in an OCI artifact. They can be distributed together with the AI models. The second benefit is that users can leverage the registry of efficient storage because the container registry use the content addressable storage to store the container images. And if you look at the model file and the OCI image, you will find the directory structure looks quite similar. We will have another picture to showcase the structure of between AI models and also the OCI image. Obviously, if you have anything in your container registry, you will have a centralized version control, and it will be easy to roll back the AI model. If you find there's any vulnerability or there's any unexpected change, you can roll back to the last version. And you can also reproduce the change for different environment, right? And obviously, you will also have a unified access control because you can leverage the role-based access control for AI models and container images in a central place. And you can also enhance your supply chain security for your AI models by attaching signatures, SBONs, attestations with the model files in the OCI artifact. That is the benefits of using OCI registry as model registry to distribute and store your AI models. So go ahead. So we're gonna deep dive into the OCI standard. So Josh, would you wanna take it?
Yeah, of course. And apologies if I went a little bit darker. It looks like my light died, and I don't know where the cord is to plug it in. So apologies. But anyway, so yeah, we're going to take a look at the OCI specification here and what this looks like. You might have seen this already. Most likely, you've kind of inadvertently seen this in GitHub or whatever your repository looks like, but you've probably not really taken a close look at what the metadata is. And what was interesting, so I don't know, it was probably a year ago, I just decided to go on a little programming adventure and figure out like how could I, like what actually makes a container, what would I need to do to create my own like Go runtime and Go packaging for a container. And I ran into this layout. I started to use the OCI and realized why every registry uses this. But if we just take a look at this real quick, I don't know if I have a marker or anything, but I'll just kind of call it out. But if you look at it, there's kind of this bigger frame that you need to look at, or a bucket called the manifest. And inside the manifest has the config, and then it has the layers. And then those layers are actually, in the case of a container, going to be the file system that are going to be archived and compressed into a particular layer. And those are all the layers. So like the first time you build it, you get your one layer. The next time you build the next one. And then when it runs a container, it extracts them all out into a unified file system that gives you all the files. So like layer 2 might just have, foo.txt in that layer, and the rest of it has the operating system, the root file system. And then the config is what would be passed to the runtime to modify that container. So if you had any kind of runtime constraints, like privilege or CPU limitations, any of those different things are going to be inside the configuration. And so what the manifest does is it puts those together in this metadata layout here that you see. So you can see in here we have the media type that it's an image manifest, and that's more of a generic container than you might think. It's not just for containers. It's like any OCI artifact can be used and then bundled in there. And then each one of those things, each item in here, the configuration, which you see that next block down below, that has a media type of config, but then it has a digest. So each of these has a digest, which is a unique address for all that content. And then if we go down to layers, that's going to be what's actually stored in there. And then annotations are actually what you'd see in GitHub. If you're pushing to like GHCR, you can take it with different stuff. Like here's going to be the URL for the project and all that good stuff. So that's kind of just like a quick rundown of what the OCI specification is. But if we can adhere to this standard, then we can push the models to any registry. We don't need to have a special models registry for it. And then it can work straight into all of our clusters or any of our existing CI/CD pipelines because we're using the standard. So go ahead, Fame, and go to the next slide, and I'll dive in a little bit more. So I guess I should have waited for this slide, but if we look at this, this is a deeper dive into all these. So we can see down in the layers, we're actually replacing, instead of using container layers and archiving and compressing, we can actually replace the layers with files themselves. So this is going to be a way how we can take those models and put them into OCI by using files instead of the compressed layers themselves. And you just see that underneath, kind of like the middle of the screen, layers. You see the media type there that is considered a layer, but then its reference is going to be the foo.txt and then the bar txt in the end there. So this is how we can use the image manifest to not only store container images with their layers, but also files. And that'll be more important later on. Let's go ahead and move to the next one. So there's two ways to refer. So this is a relatively recent development in the OCI standard. Before it was just, we're going to push a container. It has a configuration. It has layers. We're going to pull it down, extract them out so Docker can run it and other runtimes can run it. But with the supply chain work, with like signatures and SBOMs, it became important to be able to refer to other artifacts. So this is a signature. I'm just going to push it up to the registry. How do I know that it ties into this container image? How do I know it's related? So refers, there's two different ways to refer. There's a refers API, which is newer, and then there's just a refer. And I'll go into both of those. So we'll go into refer first. Refer would use a subject section. So you can see that on the right side there, where it says, okay, here are the subjects that are referring to this other, referring to this image or this artifact. And so then you can, with ORAS Discover and other tools, you can use those links because those digests, those unique addresses between things that were pushed to the registry can now have relationships built. The refers API basically gives you an API endpoint that you can relate to, and it keeps the manifest the same. There's no changes to your actual manifest, but through the refer API, you can link them. And you can see that metadata with different network calls to the refers API. So that is important for my part of the demo that I'll be doing with the signature, which is how can we relate or show relationship between and connect OCI artifacts. And then for the OCI artifact format in the model, so if we look at the container, let's see, I'm just trying to refresh on the slide. And Feynman, if you have more context for the slide, let me know. But it looks like, yeah, I'll actually let Feynman take on this one because I think, oh, this is more relevant. Yeah, go ahead and take it from
here. Do you want to go this slide?
I'm trying to recall here. Well, this is just the layout, right?
Yeah.
So, okay, yes, absolutely. So on the top here, we can see, so if we were to pull down, this one makes much more sense to me. Thanks, Feynman, for switching. Yeah, I want to compare. Like, there's actually not a lot of difference between the model registry format and the OCI format. And if you look at it, the model registry is actually using a version of OCI in this metadata here. It's just changing the format how it is enough that it is, you can't just take an existing tool for an OCI registry and use it. But we'll walk through changing that in this talk. But if we look at the top part, this would be the equivalent if you were to point ORAS, the tool we're about to talk to, and pull down the artifact, and we're going to pull down the files that it has. We're going to extract it out. So it's not just some nebulous thing up in the registry. This is actually what would happen if you pulled it down on the cluster, and it's going to extract out and run it. So we have the container dcontext v1 content. Then we have the blobs. The blobs then have a SHA, and then inside that SHA is going to be the digest itself minus the SHA. And so those are going to be all the layers of that image. And if we go into manifests, there would be the overall manifest that would have the config and then have the layers inside of that bundle it. And one of those layers in there would actually be the config JSON as well. And then Ollama, it's a little bit different. It actually splits out. It says, here's going to be your manifest directory, and for each one, so instead of each artifact having the manifest with the layers, it splits it out and says, here is the manifest, and then here's all the blobs for all the models. So they're disconnected. The manifest that has the configuration for it, and then the actual layer that holds the model are in separate directories. So.
Okay, back to me.
Yep.
So as Josh just shared, the structure, the directory structure between AI model, just like the Ollama model and also the OCI image, you will find they are quite similar because they both use the content addressable storage to store the AI models and the OCI images in AI model registry and also the OCI registry respectively. So why do not unify them in a central place?
Can I add one thing to this, Feynman? Do you mind?
Yeah,
so
please.
It just popped in my head a good analogy. So, back when containers started, there was big awareness of like, don't put your database inside the container image mounted as a volume, right? Because it's large. Well, the same thing is really true with models, and this is what Feynman's kind of setting up here is, well, what if we could store the model on the registry? That's cool. We talked about that. It could be on a different place, but how do we get that and use it inside of our container image? It's not going to be pulled down the same way the container image is to actually start the thing that's running. But what if you could take images or things that are on a registry and then mount them as volumes, just like you would a database, because it's too large to completely replicate and bake into each image. That's exactly what this feature here sets up. So I'll let Feynman take over that, but I just want to draw that analogy. Like, think of it as we have this big database file that we want to mount into our container. We don't want to bake it in and copy it everywhere. How can we leverage volume mounts for that? And there's actually a new alpha feature for and I'll let Feynman take it away, so I won't steal the thunder. But go ahead.
That's a good point, Josh. So actually, if you're looking at the relatively new Kubernetes version, for example, Kubernetes v1.31, you'll find there's a brand new feature, an alpha feature introduced in this release, which is the OCI image volume. The Kubernetes community leveraged the benefits of OCI standard to make the OCI image volume as an OCI artifact so that Kubernetes users can mount the model directory, the file directory, into a container and run it in a pod. That is very efficient, right? And you can also take a look at the Kubernetes blog post for details and its use cases. Looking at their blog post, the major use case is to resolve the AI model and machine learning model management, and also make users be able to run it in a container. So how can we achieve that? So basically, you will need to first push your AI model files into a container registry or OCI registry. So to achieve this, we will need an artifact tool to push your directory folder, your directory from local environment to an OCI registry. The answer will be ORAS. ORAS is a fully functioning OCI management tool, and it can be used with any OCI registries. Today, most of the popular container registry has supported OCI artifact, OCI 1.1, and also can be compatible with ORAS tool. So that means you can use ORAS to distribute any kinds of arbitrary files and AI models across different registries, including Azure Container Registry, Elastic, AWS ECR, Docker Hub, Harbor, and Dot. ORAS is also a CNCF sandbox project. You can use it in your on-premise environment, and it is also fully OCI standard compliant. We provide CLI command line tools and libraries in different programming languages. And also, we have a very strong community back this project, and we have the ORAS CLI supported by Microsoft, Red Hat, and several community organizations. We have ORAS Go, ORAS Python, ORAS.NET, and recently we have ORAS Java SDK. You can go to the ORAS website for more details, and also you can install ORAS CLI via different channels. Okay, go ahead. So as we can see, we have a lot of open source projects and registries embrace ORAS and OCI artifacts. So let's say, for example, Helm has integrated ORAS since their Helm v2, and also a lot of security projects like Falco and policy notation. They leverage ORAS to authenticate with the registries and also manage OCI artifacts across container registries and their local file system. And as I just shared, most of the popular container registry have been compatible with OCI artifacts. That means you can have very good portability for your AI models if you store your AI models in the OCI registries. So here's the list of installing ORAS from different channels. On Windows, you can use Winget. On macOS, you can just use brew install ORAS. That is quite straightforward and very easy to set up. Okay, let's jump to a demo. Talking is cheap, right? So we can have a live demo right now. And I also have a step-by-step hands-on article that can be shared after this session. So this is the hands-on labs that I demonstrated, that I'm going to demonstrate. As a whole, we will share how to package an LLM model. I use Ollama model as a sample model and package it as an OCI artifact. Then I will use ORAS to push the AI model into an OCI registry. And next, I will create a PV and PVC to mount the OCI artifact as a volume into Kubernetes cluster. This is just the latest alpha feature in Kubernetes. And finally, I'm going to deploy the AI model in a pod and mount the model from the OCI registry and also run the AI model inside the container. The second demo will cover how to sign and verify the AI models locally and also in the container registry. So this is the high-level process for this demo. So let's jump to the terminal, and I'm going to show you the hands-on steps. Okay, first of all, assume you already have the tool to manage your AI models. Here I'm using the Ollama, one of the most popular AI model management tool. So actually I already have Ollama on my local, and if I run Ollama list, I already have the tiny llama model put in my local file system. Then I'm going to push these Ollama models into a OCI registry. So here, if you look into the models directory, you find there are two directories. One is blobs, another one is manifest. This is the structure that Josh just shared, which is quite similar to OCI images, right? If we dig into the blobs folder, you find it has a bunch of model layers, which is similar to the OCI image layers in the blobs. And if you're looking at the manifest, it has a AI model manifest inside the manifest folder. So here are the raw files that the Ollama client tool can be used to run an AI model in a file system, right? So the goal here is to package the whole models folder into an OCI artifact and store it in a container, in a container image. So here we can use ORAS tool. I installed ORAS v1.2. This is the latest stable version in the community. So we just need to use ORAS push command and specify which directory you want to package and push to the remote registry. So here we specify the registry. I'm just using the ACR as a sample registry, but you can use any registry on your demand. And then you can specify the target directory you want to package. So here, as my model is located in the Ollama folder, so I just specify the target directory here. And you can also specify the artifact type for your AI model. So here I just use a sample artifact type here. So if I run this command, I should use a relative file path. So I just specify v2 and models because I'm already in the Ollama's folder. So here, ORAS is going to package the directory into a tar file and make it containerized in an OCI artifact. So if we run this command, ORAS will be started, package, and archive the folder into an tar file and make it as a layer of an OCI artifact. It may take some time to execute the command.
As someone who tried to build that tooling on their own, I could definitely appreciate archiving it, zipping it up, creating the metadata layout for it. So I'm a big fan of ORAS. I've used it for a number of things, even a WebAssembly component. I actually hooked into that library as well.
Yeah, I remember Josh also has a nice demo to demonstrate how to package WebAssembly modules as an OCI artifact and store it in OCI registry. This is similar to how we distribute and package AI models. So here you find the AI model has been packaged into a tar file, into a layer of an OCI artifact. So we can look at the registry side, and you will see there's a repository named Ollama Tiny Llama. And if you're looking at the tags, this is the v2 is the tag that we just pushed to the OCI registry. So if we zoom in and look at the layers, you will find there's a specific layer to store the AI model. That is
It would just be a cool way to show off some of that. This is what I end up doing. It keeps me out of the browser. I'm a terminal junkie personally, so I like if I can get away from a browser, I can. So here, this is the ORAS command that you can use to display your manifest information.
correct. Yeah,
There you go.
We can have the send JSON format on terminal, and we can use ORAS manifest fetch to fetch an OCI artifact from the container registry, and it will be the similar view with the container registry portal. Okay, I think we finished the first step, which is to push the AI model as an OCI artifact to the registry, and then we're gonna create the persistent volumes and also a piece of the persistent volume claim to mount the AI models into a container and run it into a pod. Here, you will need to create 2 YAML files for your persistent volumes and persistent volume claim, which is PV and PVC. And to save time, I already created those 2 storage stuffs. The first one is the Ollama models PV. Here, you have to specify your volume handle here, which is your image reference. We can just paste the image reference from your container registry and put it into the property value volume handle here. And next we can create a PVC to consume the PV. And here you just need to specify which PV you want to consume in this PVC. And let me show you how it looks like on my Kubernetes cluster. So here I have a Ollama models PV created on my local file system. And I have a PVC that consumes this PV. And looking at the status, the PVC has been bounded with the PV. That means we can use the PVC to mount the OCI image volume. I have also defined the pod for our AI model. So here you can just use this piece of YAML file to craft your pod. So here I have already created this YAML file on my local. So I just need to apply it. Okay, it might be in another folder. Oh, here. I just need to apply this Ollama pod YAML and create this pod on my Kubernetes cluster. So by default, the image volume will be mounted into your specified path in the container. So I just need to apply that pod and mount the specified PV and PVC in that pod. Okay, should I? Okay, there might be something broken, but ideally we should have the AI model as an OCI artifact running as a pod in our local file system. Maybe I can troubleshoot later, but there might be some configuration problem here. Let me check. Oh, there might be some disconnection of my Kubernetes API server because my kubectl is broken, but I can troubleshoot it later. So the idea here is to run the AI model as an OCI artifact and mount the image, the OCI image, into an image volume so that it can be run as a normal pod in Kubernetes cluster. And we can use kubectl SQ into the container and run the Ollama list and also Ollama run the tiny Ollama to use the Ollama model in a container. But unfortunately, the demo is broken, and I will provide a recording after this session and also share the script with all of you.
All
I will
right.
hand
Are
it
you
over
happy
to
to answer a
Josh.
question
And
before we move over to Josh?
Yeah. Shoot.
oh,
So Hack the Gibson, great username by the way, dropped in with a question saying, when you use the ORAS commands, you push the entire models directory.
mhm.
I'm assuming it's pushing all the models that are downloaded into a single OCI artifact, or did it know that you were trying to push the tiny llama one? So how do you work with all models and individual models when you're using ORAS with Ollama?
You would have to. So he got away with Feynman got away with it because he only downloaded or pulled one model, so it was only going to compress that. So that'd be one way. The other way is you would have to look at the manifest and link what layers for each model, and then you'd have to run separate ORAS commands to make sure you're only pushing the elements or the layers of the image that you want to bundle it. So he can more accurately, instead of just models and putting, or he could just put all the models in there and just like, here's the models. But he would want to have to pick out the digests for those layers and then push them as tiny llama and whatever the next model would be. Yeah.
All right, so I guess the preferred workflow if you are doing something like this is to pull one image, build the OCI artifact, clean it up, and then repeat.
That would be the simplest way.
The simplest way, yeah.
Yep.
Yeah.
All right, awesome, thank you. If there are any more questions from the audience, please feel free to drop them in the chat. But other than that, I'll hand over to Josh for demo 2.
All right. Let me see if I can move this. No, I'll just disappear for a while. My screen up?
It's up now.
All right, awesome. So we'll go with this one. I couldn't help myself from trying to get demo magic to work, so we'll see how well it works for me. But yeah, just to start. Oh. Hey, Femi, do you mind muting your keyboard's pretty
Yeah,
loud?
sure.
You got MX Blues? I think maybe.
Too many mechanical keyboards on this stream, that's the problem.
So I got the HHKBs, which is the quietest one I've ever had. But anyway, yeah, to set up this one, what I'm going to show real quickly is a new feature from Notation, which is blobs signing or in verification. And to kind of set the stage, signatures are becoming more and more important. The analogy is I actually got this from Kelsey Hightower's talk before he retired, sadly. I know he's still around on Blue Sky and stuff, but I'm not working full time. But anyway, he gave a supply chain talk a couple of years ago, and he used this really great story where, he went into a coffee shop, he found a thumb drive, and it was labeled, like latest Go packages or whatever else that for compression or whatever. And so he's like, oh, well, naturally, I'm just going to plug that into my computer, and I'm like, oh, this is exactly the source code I need. I'm going to pull it over. And he used that analogy to say, like, of course, we would never do that. We're not going to take a random thumb drive from a coffee shop and plug it into our computer, but we pull down container images and packages that way. We don't have any verification. And so signing is one way that's emerging now where we can actually have some trust with whatever it is. And so we have container image signing through Notation and other tools like Cosign, but when we're doing these arbitrary blobs, since there isn't a predefined OCI format and everything for the image quite yet, and we're just pushing random bits of, random archive or whatever, can we still use those signature best practices and supply chain security on those things? And the answer is yes. And so that's what I'm gonna show off today. So without further ado, this is the Notation. It should say blob, not blog. That's a typo. So blob signature. This is only available in version 2, the alpha. So if you don't have this one, you won't have these subcommands. So just to be aware of that. So the first thing, I've gotten the model into an archive and I've compressed it. So that's what this is. And I'm going to create a signature for that with Notation. That signature will be local. And then I will use another command in a second that will connect them, which is why we preface the talk with the refers subject. So I've successfully signed it. And let me just create a new one here so we can see it real quick. So if I do ls here, I have this signature file now, okay? We'll jump back to the demo. So now I'm going to push the model as this artifact of layers tar, and I'm going to push it to my registry. So now I have the model on my registry, and I have a signature locally, but now I want the registry to have the relationship between the signature and the artifact. So I'm going to use ORAS attach, and this is going to use the refers API. So if we were to look at the manifest, we're not actually going to see the relationship. We actually have to hit the refers API to see the relationship between them. It's not going to be in the subject that I talked about before. That's a separate way to establish relationships in the registry. So now it's attached. Now that it's attached, I'm just going to use notation ls, and this is going to show us the relationship between the image and the signature. So we can see here, here's my model. And it's yelling at me because I'm using the tag and not the digest, because that's more clear. Tags are mutable, so they could change. And so it's wanting me to use the immutable one, which would be the digest. But anyway, we have the model here, and this is the digest here. So that's another way to reference the OCI artifacts. And then underneath of that, I can see that there's this CNCF notary signature with a different digest. So that's the digest of the signature itself being linked to it or referred to it. So I'm going to create a policy, a trust store policy that will allow me to do verification. So just to create the signature, I don't need to do any of this, but if you ever wanted to validate the signature, these are the steps now that you need to follow. So I already have it. I'm just going to override it locally. So now I have a policy that states, okay, it's basically setting up what certificate should I trust for this entity, for this policy. And so this is information from the certificate that was generated that I used to sign. And so that needs to match. The trust store that it was stored in was the CA demo. So now that I have a policy, I'm going to just pull down the artifact, not validate the one that's local because that one was assigned. It's the one in the registry. I'm going to put it in a downloads folder. So now I'll pull that down and then blob verify, give it a policy, and then I'm going to point to the signature and then the path to the thing that I want to verify. And there we have it. You know, pretty straightforward. But that's how you can use the new notation blob, not blog, blob, verify and sign together to kind of secure your ACI models. That's it for me, for that demo.
Is that the demo? Both demos finished? Yes. You know,
Yeah.
maybe? All right.
Yeah, actually, I just saved myself because I just got the problem here, and I can finish my demo.
Oh yeah, over to you. Good work.
Yeah.
You could share your screen again, please.
Yeah, sure. Let me do it. That turns out that live demo is sometimes not always stable, but actually the Kubernetes cluster is not done. I actually have a Kubernetes admin to run my local Kubernetes cluster. I just forgot to switch to the root user because I install it on a root user. So the kubectl only has the access to if I run it in a root user. So here, if I apply the pod, if I apply the pod YAML file, and it will create a new pod, consume the OCI image, package it with the AI model. So here, as we looking at the Ollama model file, the YAML file, so we can see the image specifies the OCI artifact that we just pushed to the OCI registry. So we have two versions here. I use V1, that is the version that I previously pushed to the registry. That also turns out that we can have the versioning control for OCI artifact in the OCI registry. And also it can apply to manage the AI models in the registry. So here, if we apply that pod and create a new pod, then we got the we should have that pod running right now, but as the model file is relatively large, so it takes some time to create a new container here. So ideally, if the pod is running, we should be able to execute into the container of that pod and run Ollama tiny llama, run this model in the container and interact with the AI model. So here, assume we already zoom into the container, and we should be able to interact with the AI model. So who you are. You should tell me, hey, I'm an artificial bot. Okay, that's it.
All right, awesome. Thank you. So let's tackle a couple of questions and then we'll wrap this up just on the hour. But I think ORAS is an absolutely fantastic tool, right? I'm seeing it used more and more. It's almost a de facto standard now for, pushing and pulling things aren't, typically container images. I mean, even to the point, I think anyone watching this session is probably already using OCI artifacts and they don't even know it, because if you run the brew command, all of those packages are now coming from GitHub's container registry, to the best of my knowledge. So it's just it's nice to see the OCI standard and these registries being used for such non-container image use cases. What I'm curious about, though, is I'm assuming that people maybe are not as familiar with the Notary project as they are with OCI and ORAS, at least at the start of 2025. And I think that Notary version 1 was always considered quite academic and a difficult program to use. And you've shown us now that there's Notary v2 currently in Alpha 1. So my question is, if I get to it now, is the Notary developer experience improving with 2.0, and what is the roadmap like to get to a GA release of Notary 2?
Just to correct the branding, actually we should say Notary project 2.0, because we rebranded the project and we no longer use the Notary v2 as a brand. So in terms of the roadmap, we want to make sure the block signing feature is stable. And also going forward, we will support formatted output. It will be used to pipe the output to the CI/CD pipelines and also the automation scenarios. So here, all of the demos are running in our terminal, but in production environment, developers will run notation or ORAS commands in a CI/CD pipeline or in scripts. So with the formatted output support, developers will be able to pipe the output and use it in a CI/CD pipeline. So two things. One is to make the block signing and verification stable, and also support formatted output.
One quick note too, it does have a GitHub action that works for container images. So if you're worried about signing container images, you don't need to have some kind of bash script running inside your workflow anymore. You can just use an action and it gives you all the features and stuff like that. So do you have any personal experience? Like, what were some of the rough edges that you had in your mind that you'd like to see addressed? Maybe they have been, I don't know.
Yeah, I think the scriptability of it was always a major challenge, but also just, the commands themselves are quite verbose. I'm assuming there's a reason you recorded your demo, or at least set up some automation, because those commands are not an easy type, especially. So I don't think that's necessarily a bad developer experience, but it can be quite daunting following along with tutorials and copying big, massive commands.
Yeah, it does take a fair amount of context. Like, okay, well, what, like the envelope size, right, or the envelope itself. Like, I don't even fully understand the difference between the two. Like, I know that there's a difference. I know that it's changing how the signature is formatted, but a lot of that gets into cryptography. So yeah, maybe like some defaults to shorten the commands would be good. So you don't need to necessarily, what's a good default for those more verbose flags?
I think one of the other challenges was key management. People don't like having to manage root certificates and such like that.
Yeah.
But when it comes to trust, right, you've got to trust someone, and if you don't mint those keys, there is no trust. So
right. I
guess what people really should be doing is leaning in to Azure and all the other providers that have KMS, because these tools are invaluable for managing this type of secret material.
I could definitely see that. Yeah, where getting notation getting bundled in with PKI infrastructure, right? Like, to use it, you actually have to have a fairly mature PKI infrastructure, and that's a big prerequisite for a lot of people that would be interested.
Yeah. One more thing. So actually, Notation is also working with the Azure Trusted Signing Service to provide keyless signing experience.
Ooh, that would be awesome.
That would be coming soon.
All right. And you're not going to stick a date on that, are you? You're just going to leave me with soon, right?
Coming soon to a theater near you. Maybe spring. Who knows?
Yeah, I mean, this definitely is addressing some of those challenges, and I would like to see projects like this get more uptake because security is often an afterthought, and I think that is because developers have a lot on their plate with cloud native and Kubernetes in general, right? They're already going from I just want to write some code to now I'm responsible for shipping it and packaging it and distributing it and all of these things. And the easier and the more hurdles we can remove to allow people to use something like Notary and have attestations and all these things.
I would honestly, I would love, sorry to interrupt, but I would love where you can just, it's done for you on your push command, like Docker push signed. Like how awesome would that be?
Yeah, work on that, please. I think that would be absolutely fantastic, and it's nice because you could have this whole integration in the cluster. If we just speak into the registry and we get these keys and this key exchange and all this, we can do it for, OpenID Connect and stuff. I'm sure there's ways that we can bridge this, but it's all identifying challenges and solving them in time, right? And I think the cloud native community in general is really good at that. We're seeing so much progress with Kubernetes and all these other tools. I only have one more question, and then I'll leave you both to have any final thoughts that you wish to share. We've taken a look at ORAS as well now, and I love that we can push anything we want with ORAS. I'm curious about those type definitions that we have, the ability to say that this is an image layer, this is an Ollama model. Who is responsible and controls those definitions? Can I make them up to ship my raw code data layer and just type in whatever string I want, or is there some sort of OCI spec and registration process? Like, how does that work?
There is predefined types in the spec that you'll want to adhere to. It depends on what you're packaging, but if you're kind of packaging an arbitrary thing, you can you'll have to pick like a generic one, right? Like what we did with tar. So there's a couple defined. You can define your own. But then it's not going to give any help to like how it should actually be structured, but you totally can if there's nothing on the end expecting that format to be there. So yeah, if you go to the OCI, I think he had a link to it, but the OCI spec, the different type definitions, there's a number of generic ones that you could probably squeeze into, like whatever file you're going to just archive and zip it. You could use that type like we did in the demo, or you can create your own if there's no tooling, again, like on the other side expecting a particular format.
Nice. Awesome.
Yeah, actually, the industries kind of want to standardize the AI model spec. There's a working group under CNCF named Cloud Native AI Model Spec Group. We are working with them to define the standards for package and managing AI models in cloud native world. Here's the open source repository with the AI model spec.
Coming soon.
We don't have commitment right now. It's still in a very stage.
Yeah.
Awesome. I mean, it's just nice to know that all these things are being worked on, and in due course, we're making the cloud native ecosystem and landscape that a little bit easier day by day. So, thank you for your continued commitment and making things awesome for us. Do either of you have any final words to share with the audience before we wrap this up?
Just always welcome the feedback, like even just your couple notes on notation and the pain points and where that would be good. So yeah, if anybody has any feedback from this session, things you'd like to dive deeper in or questions, feel free to reach out to us. We're both on many different social media platforms. So you can find us in all those places, but yeah, just mainly feedback. If anybody has any, more than welcome to take that in.
All right, and for everyone watching this not live, all of the links and things that we have discussed will be in the description soon. I'm not going to put a time on that, but very soon. So go check them out, and please feedback to the projects. The GitHub links will also be in the show notes below. All right, thank you both so much for taking time out for your day to join us. Those were great demos, revealing aspects of cloud native and ORAS and notation. I think people should just go and kick the tires on it and try it out, and definitely provide feedback. So thank you both again, and I hope you both have a lovely day and a lovely week.
Thank you. Thanks for having us.
Thank you, everyone.
Bye all.
We've reached the end of our stream today. Hope you learned something new along the way. With Rocco, Josh, and Feynman too, showing what cloud native tech can do. Thank you for watching our OCI. you've gained will surely show. Ollama models containerized with care, mounted in Kubernetes, deployed right there. ORAS artifacts managed with ease. These cloud-native patterns are sure to please. Thank you for watching our OCI show. Your support helps rock-coded academy grow. From AI models to Kubernetes flows, the knowledge you've gained will surely show. Think you liked what you learned here today? Hit subscribe, there's more coming your way. Comments and questions we'd love to hear. The raw code community holds you dear. Thank you for watching